Hi everyone, welcome to the Tech Demos. In today's session, we are covering the advanced routing configuration using OSPF and BGP with deterministic path. Also, I would urge you to review my NSX-T deployment series so you can build your own lab at home. So let's get started. Before jumping to the lab, I would review the topology which we are going to configure. So if you look at the topology, so we have a two host. Under two hosts, we have a separate edge, H1 and H2, that would become the edge cluster. Over that, we have deployed the T0. So T0 having multiple uplinks, uplink 1 and uplink 2. If you look at there, the uplink 1 and uplink 2, uplink 1 would be connected to the VLAN 80, uplink 2, which is a VLAN 90. Okay, so further, this one, if you look at blue, so blue would be take care of the VLAN 80 traffic, which is from here to router 1, and the uplink 2 which is connected to the orange VLAN, and this is going to the VLAN 90 towards router 2. So the same connectivity is also here. The H1 uplink 1 is connected to the uplink 1 which is VLAN 80, and it's connected to the router 1, and the same behavior here. The uplink 2 is connected to the VLAN 90 towards the router 2. So if you look at that, the uplink 2 of both the edges is going to connect to the router 2, and uplink 1 of the both the edges is going to be connecting using VLAN 80 to the router 1. So this is called naming teaming policy, which we are going to configure. And after that, we are over this deterministic path or deterministic link, we are defining the OSPF. So this is going to be all the neighbor going to be part of the OSPF area 0. So let's jump to the lab. So this is the lab which we have. So if you look at there, we have two hosts, and we have already deployed the edges. So if we looking at T0, T1, we don't have any configuration as of now, which we are going to configure. And if I'm following the topology, so this is what we need to be achieved. So over router, we have one client VM, and this is these two are the VIOS router, and those are configured at the VRRP. So this is the gateway where dot 1 is a floating IP. So where 2 would be the 2 and 3 would be their IP. Okay, so let's start and do the configuration on that one. So first we need to configure the deterministic path or deterministic peering, which we can say. So on that one, we need to configure the edge 1 and edge 2 as a defined profile, where we have the VLAN 80 and VLAN 90 going to be talking individually. Like uplink 1 is going to be participate under the VLAN 80, and uplink 2 going to be participate for the VLAN 90. So let's start configuring in that way. So first we need to jump to the profile. So we need to define the profile here. This is the edge profile which I have created. So that profile having the VLAN 40. So let me amend this one as a 40, and then we need to define naming teaming policy. VLAN 80 is uplink 1, VLAN 90 uplink 2. Save. Okay, so transport zone, since this is already in use, so for the edge we are defining a new transport zone. So let me define the edge transport zone. We can use the VLAN existing VLAN backed transport zone, which is VLAN TZ, but we don't want to touch that one since that is already been called under the host. So we're defining a new edge TZ. Here we need to call it out VLAN 80 VLAN 90. Okay. So two zone we have defined, and let me go to the edges and modify the edge settings. So in the north I need to modify the VLAN here, so we can configure these uplinks going to be picked the deterministic path. So the VLAN 80 going to be uplink 1 and VLAN 90 going to be the uplink 2. So this has already been there. Yeah, we need to remove the VLAN TZ here and define the new TZ which we have edge 1. Okay, and prior to that, let's create the uplink on the VDS, since we have to define VDS here as well as. So I'm creating new distributed port group VLAN, or let me define a trunk VLAN 80. I need to call multiple VLANs here. First VLAN would be the VLAN 40, which is a tap VLAN. The second would be the VLAN 80, which is for the uplink 1. The same way we need to define trunk VLAN 90. Next, trunking 40 and 90. Next, and then do the configuration topology. VLAN 80 going to be picked the edit setting, teaming policy, used. VLAN going to pick the uplink 1, and this one is going to pick the uplink 2. Okay. So now VLAN 1 or VLAN 80 is going to be uplink 1, VLAN 90 going to be uplink 2. Okay, this is fine. So let me go here, and now I'm going to modify this one. Edge 1, edge TZ, and deleting this peering, and VLAN 80 going to be uplink 1, and uplink 2 going to be VLAN 90. Okay, click on save. Same way I need to modify the configuration of this edge as well as. I need to remove VLAN TZ. I need to call the edge TZ here. Okay, we got the success status now. We got the success status. So let's move to create the defining the segments. Trunk segment where we need to connect our tier 0's uplink. So this is going to be a VLAN 80 connect to the edge TZ. You need to pick the VLAN 80 here, define VLAN 80 here, and click save. The same thing we need to do for the VLAN 90. VLAN 90 here as TZ, VLAN 90, 90. Click save. No, that is fine. So now click on system. One thing which we missed, we need to create the edge cluster. As of now we don't have any edge cluster, so let me define the edge cluster. Edge cluster 01, bring both, right. So let's start configure the T0 gateway. So this is our topology, and T0 gateway 01. Pick the cluster here, save, yes. Define the uplink here, set add interface, uplink 1 edge 1. So edge 1 uplink 1 external, IP going to be 192.168.80.2, 192.168.80.2/24 segment which we have created for the VLAN 80, this one, and the edge 1. Save, add interface, edge 1 uplink 2, edge 1 uplink to 90.2, 192.168.90.2/24 edge 1 uplink 2. Now we have configured these two. Now we need to configure this for this edge. So edge 2 uplink 1, edge 2 uplink 1, 192.168.80.3/24 80. Now we need to pick the edge 2, save, edge 2 uplink 2, 192.168.90.3, correct, /24 VLAN 90 edge 2. Okay, so these are the interfaces which we have created. Okay, that is fine. We have defined the interface. Now we need to disable the BGP and enable the OSPF. Enable the OSPF here. Set area definition, add area definition, make it 0, backbone area, save, close, configure interface. So here we need to configure the interface. Configure interface, set, click on set, configure interface, define uplink 1, area 0, that is going to be broadcast, save, configure uplink 1 or edge 1 uplink 2, area 0 under the broadcast. You can also configure if you have NBMA kind of stuff like non-broadcast or P2P, so you can define in that way as well as S2 area 0, save. In the last interface H2 area 0, then save. Okay, then refresh it, close it, save. Route summarization. Need to disable BGP, enable the OSPF, set, add, remove this one, add OSPF, redistribution, static, or make it connected, that's it, connected, set, connected, and connected for both, add, apply, save. Okay, so this is the tier 1 configuration which you have made it. I'm just refreshing it. Now you can see the status showing down because wireless router we have power off. So if I'm going to look at here OSPF neighbors, we have two-way neighborship which is in between the edges. If you look at 90.2, 80.2, so these are the in between interfaces, so that's why they have configured two-way. So we need to form that neighborship for the wireless router. So let me enable it here. I'm just powering it on. Okay, so routers are up. So let's see the connectivity now. Okay, so we can see that 90 there we have 4 neighbors, 90.1, 80.1, 90.1 and 80.1, and these are the router ID. From those router I'm having the higher router ID. Our interface IP would become the router ID, and this is the neighbor. So if you look at the topology, we have edge 1, it's having the 2 neighbors which is a 80.1 and 90.1, and edge 2 having the 2 neighbors 80.1, 90.1. so those made it on the VLAN 90 and VLAN 80 if you look at this one. Okay, so let's jump to the T1. Let's create the T1. T1 gateway 01 distributed only. Since we are touching the since we are working on the lab, so that is the reason why there is a delay. That is the reason of delay. I have clicked on save, probably it's going to push. I have to pick the distributed only here. and then route advertisement, select the connected only, save. No. Okay, so let me jump to the segments and create a test segment, or let me see. Yeah, we don't have anything. I'm defining a test segment here, test segment connect to the overlay TZ VLAN, and this is going to be connect to the T1 gateway. IP which we are going to assign for this one is 172.16.10.1/24. Click on save. Perfect. And click now and refresh this one. And if you go to the network topology, we can see the topology. So we have a fine, just increase the size. So 192.168.90.2, 80.2, 90.3, 80.4. This is the interface here. These are the peer, and it's formed the neighborship with 80.1 and 90.1, and 10.1 is a gateway for that. And let me look at that. So we have a 2 VM, VM1 and VM2. So let me power it on. I'm powering this one on, and assigning this to the test segment, this one. Okay, and this is the client VM. So we have one VM here, which is your test VM, and we have one VM here. I'm powering these both on. So this is the VM we have as a client VM. So let this come up until we are, look at the configuration here. Okay, so this is the one VM, this is the client VM, and this is our web VM or test VM, which sits on the test segment. So let me quickly go here. Okay, 70 10.11. Let me try to ping the gateway. So we have the connectivity with the gateway, and let me see this VM. First let me see the IP config for this one. 10.12. this one is a 10.12. this, and the gateway is a .1. Let me ping it. 192.168.110.1. okay, this is pingable. Okay, so let me quickly look at the routes here. Show IP route. I have the route from the OSPF. If you look at that, 192.16.10.0 from 80.2 and 80.3. If you look at that topology, router 1 having from 80.2 and 80.3, that is a good sign. And for okay, and let me look at the router 2. Show IP route. The thing, if you look at this one, this route 10.0, which is a NSX segment being learned from 90.2 and 90.3. So router 2 learning it from the 90.2 and 90.3. Okay, it means we are learning this one, and if I'm jumping to my edge, let me try. So I'm jumping to the edge, admin get logical router. Okay, so VRF1 get routes. Okay, so here's the thing. Okay, you can see we are learning this route from two peer 192.168.110.0. This is the route, this is the our VLAN network, and being learned from two peers. If you look at this one, Edge is learning this network from 80.1 and 90.1. if you look at that one, and both having a different uplinks. This is what I want to show you. This is the uplinks. So probably we are fine with the routing. So let me initiate a ping and let's see what is that would be the response. Ping 192.168.110.12. Okay, we received the ping. This is pinging, and let me look at the reverse one from outside. This is also going to be ping. One 192.168. One 172.116.10.11, I believe, sir. Here we go. We are able to reach those network. And if I'm going to trace it, probably we do 10.11. Okay, so you can see the routing that is in place. We are able to reach from this one. The first gateway would be 80.3. This one is a gateway which is a 110.2. This one, then this, then the VM subnets, which is a VM itself 10.11. and the reverse if you want. Trace out -D 192.168.110.12. Okay, so this is also fine. So this is the beauty of a deterministic path or deterministic routing. The reason why I have shown you this topology. So this router purely, carry the VLAN 90 traffic. This router purely carry the VLAN 80 traffic. But in the end, the overlay and underlay doesn't aware about that traffic. It picks this one to go out and this picks one to move out. So in case of one router failure, the second router would take care of the traffic based on since we are using the multiple VLANs for cater the same kind of traffic, and based on the uplink we have defined that one. Thank you. If you're enjoying our content, so don't forget to like and subscribe and ring the notification bell. Thank you.